Welcome, everybody, to RHEL Presents episode number 76. I am not your host, Eric Hendricks. I'm Nate. You might recognize me from Into the Terminal. I'm standing in for Eric today because he had some life things going on, although he is hiding in the background. So maybe he'll jump in at some point. We don't know. Hi, Brian. How's it going?
Good. How are you doing today, Nate?
Not too bad. We're going to be talking about some new features in Podman 5.0 today, and we've got a couple of guests to get that done with.
Yeah, super excited. Podman is always a super interesting thing to talk about. Lots of innovation there, just really fast moving applications. So yeah, super excited for today's episode.
Oh, I love Podman. Podman's a great feature of RHEL.
So
all right, so welcome.
Yeah, who do we have here today? welcome, Mark and Brent.
Right.
You guys want to go ahead and introduce yourselves? We'll start with Mark. Tell us a little bit about you, Mark.
Sure. Hey, everybody. My name is Mark Russell. I'm a product manager at Red Hat. I'm responsible for container tools and Edge in RHEL, and as well as RHEL Core OS and OpenShift. About myself, I like to spend my extra money on weird records, and I'm here in Queens, New York, with my 4 cats and fam. So it's great to be on the show. Nice to see you guys.
Awesome. Welcome.
And I'm Brent Baude, and I'm on the container engineering team, and I am currently the architect of Podman. I was one of the initial engineers that broke it out, a small portion of it from a different project, and built it into Podman. Back then we called it K-Pod. I spend my personal time here in northern Minnesota hunting and fishing and doing normal Midwest things, and excited to be here.
Awesome. Well, welcome to the show.
Thank you.
Thanks.
Yeah, so let's start, in case there's anyone watching who hasn't ever heard of Podman. Can one of you explain, what is Podman? What is it used for?
Sure. Podman it stands for Pod Manager, and of course it has its roots being very similar to Docker initially. So if you know that, you know Podman. On the other hand, if you don't know that, we create, manage, and run containers, and we provide a framework to be able to do so in a command line utility. There's also a complementary Podman Desktop web utility that has gotten very popular, that's in particular for Windows and Macs. The containers we're talking about are Linux containers, so they have to run in Linux. But we do have ways to run them on a Mac and a Windows as well.
Yeah, containers are a Linux construct, so that's pretty much how it works in general, right? So for Podman Desktop, yeah, you can imagine if Docker Desktop is giving you ideas of what it is, that's basically correct. But it can also work. It works with pods. It works with OpenShift and Kubernetes and client clusters. Frankly, you can even manage a Docker daemon if you wanted to. So it's pretty neat.
And we had an episode not too far back, episode 56, where we did talk about Podman Desktop. I forget. I might have even co-hosted on that one. It sounds really familiar.
Feels like might be maybe some good updates coming soon. So might be time to bust that back out.
I mean, I'm sure it's moving quickly, right? So maybe.
Very quickly.
In fact, all the Podman projects, as was mentioned at the kickoff, are still, from an engineering standpoint, moving very fast. Every release has got features for sure in it, and we're still moving very fast.
Yeah, I've been following Podman myself since RHEL 8, which is, I think, when it entered the full production status in RHEL. In fact, it might have even been tech preview at that point. And because I was coming from Docker, right? And some of the features that I saw in Podman, like rootless containers, the introduction of pods and how they work, that was really attractive. And of course, I've been a RHEL guy for a long time, so I was really happy to see a tool like that So yeah, it's definitely changed a lot since those, what was it, 2.x days when it came to RHEL 8. So, or maybe it was even 1.x. But yeah, great tool. Great tool.
Yeah, we had a 1.x in RHEL 7.
So we have Podman obviously packaged and available as part of RHEL. But I think one of you mentioned you can also use the upstream Podman if you're on Windows or Mac. Can you talk a little bit like how do you use Podman if you're using Windows or Mac as your workstation?
Sure. If you go to the Podman IO site, that's probably the best way to sort of wiggle your way through. We're also at github.com/containers/podman. And then in there are our releases. So if you want to run the latest upstream release, which would be 5.0, having just come out, you would go there and Mac or Windows selection. You'd also have to choose the right architecture and download the appropriate binary for yourself. And then from that, you have what we refer to as a Podman client. The client is capable of all the GUI, the command line portions of the GUI, if you will. And it's really what's doing the interacting. But what it's interacting with is something that has to be on Linux, as we mentioned earlier. So in the case of a Mac with Podman 5, it uses the native Apple hypervisor, creates a VM, loads a custom Fedora CoreOS into that, does a bunch of knob turning and fiddling, and then when you issue a command like podman run, which is the base command for running a container, it will run that container inside of that virtual machine. On Windows, we offer support for Hyper-V and the Windows subsystem for Linux WSL. We're working right now that the installer will always choose WSL. We're working on enhancements to the installer where you get an option, but you can use one or the other. And it's essentially the same idea. The client is capable of creating, in the case of Hyper-V, it would be a Hyper-V machine with the same basic operating system in it, same level of interaction. With WSL, it's a little different. It's actually a custom Fedora distribution, and same idea. It loads that into its WSL framework, and off you go.
Very cool. And
so
so
there's a lot of, just one second, there's a lot of back and forth there about the underlying subsystem behind the different operating systems and like how these containers are being executed. So I want to address if anybody has any like concerns. Oh, but if I'm running it on RHEL versus running it on Windows versus running it on Mac, right? A container is meant to be a container, right? So it's portable. It shouldn't matter as long as it is compliant, right? Built to the right standards. It should run on any of these platforms in the same way, right? Are there any caveats to that we should talk about?
Generally not. If you get into some real intricate details around subscription manager running on Fedora type things, but they're all pretty well done, and people are doing this all day, every day. Obviously, we also have cases where they might be running in a, God forbid, a Debian container, and that works equally as well. It's not a RHEL Fedora thing.
Do we have to tell the producer that you brought up Debian on RHEL Presents? Is that
okay? It was a Gen 2 container. Okay? Is that better?
Gen 2 container.
So one of the really unique things about Podman is that it's daemonless, right? You don't have to have that long running daemon managing Podman on the system, and to kind of accommodate some of the requirements and needs though that are frequently encountered. There's a lot of integration or interactions between Podman and systemd. Can one of you talk about how does systemd fit into the picture when you're working with Podman on a Linux system?
Mark, you want to start that, and then I can maybe provide a little more detail if we get there.
Yeah, so up until somewhat recently, systemd integration was still possible, but each container, right, has an ID. Each container image has an ID on your system. So imperative commands would have to be run, and then a systemd unit would be generated by the generator. And that unit file is not something that you could take and push to other places because those IDs don't match. It's not portable. Quadlet files basically take that boilerplate. They do two things. One, they make it portable and declarative. They're also familiar to a systemd administrator. They look like a typical unit file. And basically, if you want our kind of opinionated, here's how you would run a container as a service, it's very simple to set up. If you want to change any of those defaults, it's very easy to override. And you can really just, again, by just dropping a file like you would with a systemd unit, you're dropping in a containerized service.
And then at that point, you can then use your normal systemctl commands, right, to start, enable, to start a boot, et cetera.
Restart,
right?
It really works just like any other service.
Very cool.
And we've got a lab that we can show that in if we're ready for that now.
Let's go for it.
All right, so this is actually a lab. I don't know if we're going to share the link, the live stream or not, but it'll be in the description of the video. This is a lab that you can actually go do on your own on our published labs, right? It's a lab that I wrote. We're going to walk through like a very, very abridged version of it right now. So if you want the full thing, you're going to want to go check it out. So first of all, I'm going to use Podman here to make a pod. And if you're not familiar with what a pod is, it's basically a grouping of containers, right? So you put your containers within a container, essentially, is the best way I can describe it. But it also manages things like networking. So these containers can talk to each other within the pod. In this example, we're only using one container within there, but you'll get the point, right? So we're just going to do a pod create, give it a name, and we're going to pass in a port. Now, this is the same syntax you'd use if you were passing a port from the host to a container. In this case, you're passing it from the host to this container of containers, right? And the containers within the pod don't have to necessarily, you don't have to expose all the ports, right? So if you have a database in here, for example, and a web application, the database port you probably don't want to expose, but the web port you probably do. You don't have to expose the database port. The web application will still be able to talk to the database backend. But again, I'm getting deeper than this demo is going to go into. I'm just trying to give you guys some background. All right, so the next thing we're going to do is we're going to put a container in that pod, right? So we're going to run a new container. We're going to run it in detached mode. We're going to specify what pod it's going to go into. We're going to tell it the name of the container that we want to give it. You don't have to give it a name, but I like to because they're easier to find later. And we're going to run a container that I built that's already built into this lab called HTTPD. It just basically takes Apache and runs it within the container, right? So that string of numbers and letters there simply is the acknowledgement that it's there. Now, if we do a Podman PS, we're going to see two containers running. One is that container of containers, the pod, and then the other is the networked HTTPD container that I just made. You can also do a Podman pod PS, which shows you just at a pod level. If I had a dozen containers within this pod, it would give me that number of containers right there. It would say 12 or 13, I guess, because you also include the pod container. It's like a controller container. However, if the number of containers was fewer than the defined number, right? So if I had defined 12 and 11 of them were running, it would tell me it's degraded. It's a really handy thing, right? So you can get a quick overview of how your services look and whatnot. All right, and just to show you that it's working, we're just going to quick use curl here to show you that we're getting some web output from our container. Just says, the good old Apache it works page. All right, now let me clear the screen here so we don't run off the bottom. Now, here's where the fun really starts. We're going to take that pod and we're going to generate a YAML file, which will basically redefine that pod or allow you to redefine or redeploy that pod elsewhere, right? So just a sec here. Got to copy the right command out of my notes here. I was getting ahead of myself. Wouldn't have worked. All right, so Podman generate is that generator that I believe Mark was talking about a second ago or a minute ago. where we can generate, you could have generated systemd files with it before, which is what he was talking about. I'm going to generate a kube file, right? And what this is going to do is it's going to dump it into this YAML file that I've defined. And then if we look at this, mynetworkpod.yaml, you'll see it's really simple. It just gives you the specification for what this pod should be called, what containers run within it. I didn't do anything complicated here, so it's actually really short, right? If you had a dozen containers in here, like my example before, there'd be a new one of these blocks here for each one of those containers, right? It tells me what image it's using, what to name it, what ports to define, things like that, right? Now, we're going to take the pod that we made and we are going to stop it and destroy it. Because, like I said, we're going to be able to redeploy easily using this YAML file. So we're going to do podman stop on the pod, and we're going to do podman rm on the pod. So now we do that. It stopped it, then it removed it. Pod ps tells us there's no more pods. Now we're just going to redefine it using this YAML file. All right, we paste that back in there. Podman play tells it to take this file and replay it, right? And it's just going to do its thing, and it's going to spit out the IDs of the pod and the container. We do a pod ps again. There it is. It's back. If I go back to my curl command, you should see the same old. It works, right? But we're still not done. We're going to do one more thing with this. We're going to stop and remove that one more time. And let me clean the screen up again here so we're not running off the bottom. All right. There's another file here called, which is part of the lab, right? You don't have to write this out. And to save time, I didn't recreate it. Hold on, I messed up my paste. So mynetworkpod.kube. Okay. This is one of those Quadlet definitions that was being referenced just earlier. And this is, if you look at it, right, it's a systemd unit file. And you can see the usual syntax you'd expect out of systemd, tells it what target to put it in, tells it what it should run before and after, things like that. But down here, we're telling it, the type here is kube, and we're telling it what file to use here. And I realize that overlay is blocking what I'm trying to show you here, but we tell it YAML, and then of course there's a path to where this YAML file is. And that's the same YAML file we just generated, except I haven't put it in the right place yet. And we tell it what ports to publish, because we had to do that when we made the pod, if you remember, right? So now we're going to take the files, the kube file and the YAML file that we generated, and we're going to put them in a special place, which I will show you in a moment here. Etsy containers systemd is a special directory where you place these files so that you can have systemd read them in and generate them as you need it. So first we'll need the YAML file, because that's just the path that I told it to. It doesn't have to live there, but for the sake of keeping things clean, I like to put them there. And we're also going to take the kube file that I just showed you a minute ago. We're going to put that into systemd as well. The right thing there. And then we're going to run Quadlet in a dry run just to show you what it's going to generate. Okay. Now, when I say generate, systemd or Quadlet will actually generate these files and make system units out of them, right? So we're going to paste this in here. So you see user libexec podman Quadlet -dry run will run a dry run and just output to the screen the service definitions that it's going to create. And you're going to see it's going to make a mynetwork-pod.service. And this is what the service is going to look like. Now, the one thing I want to call attention to here was this exec start. It's literally calling podman play cube or podman cube play -- replace. What that means is every time you stop and start the service, it's going to reread that YAML file and it's going to recreate the pod, right? So what that means is if there's a new definition of your containers, all you have to do is restart that service. It'll pull down the latest version of the container and rerun your service, right? So in my case, I use this thing to manage some services that are published on like Docker Hub, for example. When I want to update them, I just restart the thing, and then I double check to make sure that things came back up. And it's so much cleaner and easier than having to go through and redefine a pod or redefine a container, right? So that's really helpful stuff. But what you really care about is, does this work? So we're gonna show quick, nothing up my sleeves here. There's no pod running. There's no containers running, right? Everything's clean, good to go. We're gonna do a systemctl daemon reload. No AD, if I could type. And what that does is it tells systemd to read the, to generate those files that we did with the dry run, and it puts them in place. And now if I do a systemctl start on, I want to type this out because I will definitely mess it up. Copy, paste this my network pod.service, which is the service file we saw it generate in that dry run. It's going to run the container. It's going to run the pod, I should say. Now, if we do a systemctl status on it, and this is actually one of the cool things, you can check the status of the pod right through systemd now. Right, and you see there's red text here, but that's actually just because when Apache starts, it throws out things that systemd is interpreting as errors, saying that it couldn't reliably determine its host name. That's all just normal Apache stuff. The important thing here is that it says it's active and running. So now if I close that, clear the screen again, I do a pod PS, there it is. There's our pod back up and running. Same number of containers. And if we did that curl again, you should see it works. So there you go. I've now got a pod that's being managed not just through systemd, but through a YAML definition in systemd, that all I have to do is restart through systemd to pull in updates. I think this is real slick. So nice work. I'll just say that.
Yeah, make sure you're pointing at, I assume that was at Brent.
Whoever.
And team. The other nice thing is when you start working with Kubernetes YAML, right? That's something that you can then take that and maybe build on your local workstation and apply to a kind cluster or to a full-blown Kubernetes cluster without much effort, perhaps none. So
yeah, I've always been kind of curious about that. I don't have a Kubernetes cluster that I can try it with. I've always wanted to try that though. Take one of these definitions and just throw it at Kubernetes and see what happens. I'm told it's supposed to work.
It works.
Good.
It works.
And I believe Docker, 50 lashes. I believe Podman Desktop it assists you in installing kind if you want to do that as kind of a local test. So it's pretty neat.
I think it can also help throw that YAML at a I was going to say OpenShift, but yeah, that's where you want to put it.
Indeed.
So
Into
Kubernetes.
So we did have a question in the chat I want to address. So the question, if I understand correctly, is basically, if I've installed Podman on a Windows workstation, and I have a remote host running RHEL, can I use my Podman installation on my Windows workstation to interact with the RHEL system? Basically, use that RHEL system as where the containers are running.
Absolutely. In fact, that function was long there before the VM based one that we talked about, and it's a reasonably easy process. There's something called a Podman system connection. It's a sub command in Podman, and that will you can set up a connection via SSH to, say, a RHEL backend, and depending on the user that you set it up to, rootful or unprivileged, you'll get that experience. And you can then just issue the commands on Windows, and it'll just be using the sort of an API to go back and forth on that.
Very cool. And then just to circle back, so we talked a lot about Quadlet, Kubernetes YAML, as well. And I just want to throw out there as well, we do offer a RHEL system role for Podman. If you're not familiar with the RHEL system roles, it's Ansible content provided in RHEL that you can use to automate all kinds of different things. But anyways, with the Podman RHEL system role, you can actually use it to help if you have Kubernetes YAML files or Quadlet files. You can use it to basically automate deploying those out to your various systems in your environment. So would encourage everyone watching, if you're interested in Ansible automation and working with Podman, check out that Podman RHEL system role. Is there anything else we want to cover regarding Kubernetes YAML, or Mark and Brent? Or do you feel like we've covered that pretty well?
I would just comment that we've got also people. Nate certainly showed a way that it's being used, but we've also got folks using the YAML kind of in the spirit of what Mark was talking about. So they do use the YAML, they generate the YAML locally to get it kind of figured out and it's all working. Then they might throw it out on into Kubernetes and test it there. But one thing they also use, and I think Nate hit a couple of those commands, is there's a generation command for the YAML, and then there's sort of like a replay. And so some people do use that YAML as a way to sort of local node orchestration of a few pods or containers together. And we see that working quite nicely. Doesn't involve any extra software to be added in or anything like that.
Yeah, we were talking about that evolution of Podman. I used those Kubernetes YAML files just the way you described before I learned, or maybe even before Quadlet was fully fleshed out, right? So I was doing it exactly that way, almost like a replacement for Docker Compose, right?
Something like that. Yeah. And again, the one thing we like about it is it's portable. You can take it to other platforms and whatnot, and should work nicely.
So we recently released RHEL 9.4 beta and RHEL 8.10 beta, which had a new version of Podman. Can you talk about what are the highlights in those beta releases regarding Podman?
We've got a few highlight items there. I think let's start though with maybe something that's a little bit hidden from the users, but might be cool for our staff. We're changing the database on the back end for from BoltDB to SQLite, and part of that, at least some of that came from power pull the plug type tests that our partners were doing. So we have partners that build appliances based on Podman. Of course, their customers treat it like an appliance, so they need to know, right, that it just is going to keep working. So sometimes we had corrupted databases, and we had difficulty with that, and so we're moving to a database that's in our case, it's going to be more reliable and I believe more performant as well. That's just sort of a bonus, and maybe Brent will get into some more detail.
Sure. Yeah, like Mark said, it's largely based on partner feedback. We just found that that Bolt just didn't give us what we needed, even though most container runtimes were based on BoltDB. And so the new one is an SQLite implementation, and we've had great success with that. We do support both. In Podman 4.8, I believe it was, we switched the default. So if you've never run Podman before and you issue a command, we're going to generate an SQLite database. If you're running something previously and it was BoltDB, that will be unaffected as well.
But you can switch if you want, right?
Absolutely. And I don't know if now or later I can kind of show a demo how that goes, and it bleeds a little bit into Podman 5 as well.
Maybe we'll put it on that section then. Makes sense. Yeah, so the other things, I'll tick off a few, and then I'm going to reach back in time for something that's not brand new, but I think it's still pretty cool to point out. Brent mentioned Apple Hypervisor support before. We'll also be in the future getting, this is not a 9.4, 8.10 thing, but in the future that Apple Hypervisor support will include Apple GPU pass through into the Podman machine. So we're going to keep working on that. Podman machine reset is basically just, kind of what you would expect it to do, nuke your system from orbit. What else? Modules. So modules, I should give you a visual, but let's say you have very complex command lines when you're launching Podman. There are an enormous number of switches if you go look, and sometimes you need to use quite a few of them. We have customers who, for example, have to map GPU support like NVIDIA into the running container, and that involves setting some environmental variables, involves like several bind mounts from the system tree, and modules basically allows you to take all of that, put it into a single configuration file, and then call it on a command line. So just imagine instead of having 5 to 10 switches to set up the NVIDIA mapping, it would be -- modules NVIDIA.conf, right? And if you especially for somebody who needs to switch between a bunch of different sets, this can make the command line be a little bit more manageable and stop looking like some enormous QEMU, command line. So that's pretty neat for people who have very, very extensive sets of switches. Multi-arch build farm is something that's going to be a tech preview in 8.10 and 9.4. This is not cross compilation, just to be clear. It's where you have different systems of different architectures connected by Podman system connections. Like a classic case might be I'm running on an x86 workstation. I have a Podman system connection to an ARM server. So I can issue a command I can have a build farm, which represents those two machines, and do a multi-arch build where that ARM build will be dispatched to the ARM machine. It'll all be brought back, it'll all be pushed together up to an OCI registry linked by a manifest. And Brent may talk a bit more about manifests later, but so multi-arch build farm will ease that. And hey, let me show you a couple things on health check actions, which is something that came a couple of versions ago, but sort of worth looking at. Hopefully I have this all in my head in the right order. All right. So I wrote a health check script to write. It's one thing you can put in your Quadlet to say, what is it, service restart always or something, but that doesn't tell you if your service is actually working. That just tells you the container is running, right? So if you want something to make sure your service is a bit more resilient, you need a health check. So here's one that I created. Well, I didn't create. I copied from our friend in engineering. We wrote a blog post. Originally I was writing a line there, wget, to kind of just test the web service, but I was messing around, had some difficulty killing the service. So we're just going to do a really artificial one where if it recognizes the presence of a file called in the root directory of the container, it is going to exit with a non-zero status. And hang on one moment. And so we can have a few different actions that a health check can take. Restart, stop, kill, or none. None is the default. Kill, you might wonder why, but you might use kill on the service side in conjunction with systemd saying restart always. So let me give you an example. So I have this service that I use. I have this containerized app that I like called Navidrome. I'll drag it over here to show you. It's sort of like, right, it's like a little home Spotify for your MP3s. And this is something that I pulled down from, it's on GitHub and whatnot. Anyway, advertisement over. So let's see what we got here. I've got the health check, and let me first show you my old Quadlet file. Okay, so in this one, it's pretty straightforward. I have a couple of bind mounts there under volume. This is the base image that I'm pulling from, the port that I'm publishing. I have a couple of Podman arguments, so anything that, like I said, being done, you can override. In this case, I had a little bit of trouble with my security labeling with using my MP3 files in the container and outside of the container. So unfortunately, my solution was to disable the labeling. And I have a label there to set the container to be auto update. But as you can see, otherwise it looks like very straightforward systemd file. But back to the health check. So that's the upstream container. But what I want to do is build a new one, and we'll call it navidrome-hc for health check. Oh, I didn't show you the container file. So it's very simple. It's just from the exact same image, copy the health check to the health check location and make it executable. Oops. Could do this with Builda, but we don't need to. All right. So there's a couple warnings here, which I determined are not not that important. Basically, health check is something that came out of Docker originally, and it didn't actually it's not part of the OCI spec. If I add a switch and change the format from OCI to Docker, I can get this to run without complaining, but the warnings are actually unimportant entirely, so it works anyway. So what I'm going to do is I've built that. Now I have another Quadlet file up there with a copy of the service. Right. So in this case, I'm not going to do the bind mounts because I don't need this to actually see my music library. But I've added a bunch of other switches for the health check. One is to tell it what the health check command is. Second is what policy I want. In this case, I'm going to do kill. Third, I changed the default. I think it's 30 seconds. I didn't want us to have to wait that long. How many times it retries, that can be modified, until it determines that's a real failure. And then there's a health start period in there, which means maybe you want to give it a little time to initialize your service before making sure whether it's healthy or not. And there's some environmental variables I don't need. So we will start the service. I just run it. I personally run it. My service is as a user service because there's no real reason not to, and why not contain this? And if I go over to Podman Desktop, over here you'll see that actually I already had a Navidrome service running. That's my production version, if you will. And I have a second one here that has booted up. Looks like it's launched fine. And let's get a shell into there, or we can do that also from here. So let's Podman exec. And we're inside the container. And within a few seconds of creating the .o file, we should, and if you'll also, let me just have this here. So you'll see it disappear there too. We'll touch .o, and we've been killed out, and the container has been stopped. So it worked, hooray. And that is that demo.
Pretty nice. It's handy, right? I mean, being able to have the container test itself for its own health, right? I mean, and
this was in fact
restart or take some action, right?
Yeah, this was in fact another partner request, and they need ultra reliable services out in the field. They actually are involved in safety issues, and they have radio base stations that it's not even a truck rollout that they're worried about. It's somebody having to run a snowmobile out miles and under 5 meters. So they really, it's very expensive to have somebody go fix it. So something that can keep the services alive at the edge is super useful, and they don't need the overhead in that case of a full-blown container orchestration system to get the benefit out of a containerized service. And at least, some modicum of HA.
And, obviously there's certainly failure cases where the container would have stopped, and that's pretty easy to detect. But if it's up and not working right, that's just as bad as down, right?
Indeed.
So being able to do a health check, something that's more intelligent than just if a file exists, right? But actually do some sort of unit test that says, yep, it's working, or no, it's not. And then take action. Yeah.
Yeah, I mean, it could be like a database query. It could be,
Right.
curling a URL, pretty classic examples, but something beyond just, is the container running, because it's can be completely misleading. Let's see, do we have anything else on the list? I think that was pretty much it as far as what we wanted to talk about in 9.4 and 8.10. Certainly open to any questions on that.
Yeah, very cool. Do we want to jump back to the how to migrate from Bolt to SQLite? Talk about that a little bit more.
Sure. How's our time?
Yeah, I think. Well, how long does that take, Brent, to demo that?
It goes pretty quick, but everyone could just trust us and say that it works, and we can move on to the next stuff. Whatever you like.
Got a little over 15 minutes left, if you want an actual time.
Yeah, let's buzz through it. Give it a try. Okay, so once my screen gets shared here, I'm going to go silent on that. And we talked about the database changing, and it's moving from something called BoltDB to SQL. So I just want to walk through this a little bit and just kind of show folks how this works, and in case they get into some sort of a special case here. So if I look and run a Podman command, and you'll see here I have a Podman 4 and a 5 on the same system. If I ask Podman what kind of database it's using, and I'm using Podman 4, and it's an old enough version like 4.7 or 4.6, you'll get a response out of Podman info that's using BoltDB. And I'm just going to run a quick container here. And show a PS. Oh, did it run? All right, so we've got a container running here. Now, if we were to just either through upgrade or we decide to change to Podman 5, it should behave exactly the same, which it did. And if we look at the info, it's still reporting that it has a BoltDB. All right, so this is where things get a little tricky then. So if I'm, just to prove that it's the same output. If I decide, however, I want to do, I want to switch, and I want to, let's see, do a system reset again. This is basically just completely wiping out everything. And now I ask Podman 5 the same command. You see that it has defaulted over to SQLite. So that's kind of how this is working. Is we'll carry you through as long as you have an existing one, and then if we have to recreate it, we'll recreate it as SQLite. There's one little edge case here where if I start with a clean system here and I have something, if folks know about containers.conf, just to show what this looks like. It's a basic stanza-based file, YAML-based file that allows you to customize how Podman is going to behave. And some people will go in here and hard set the database backend. If you don't set it, you just get the default. Some people will hard set it for any number of reasons. If that's the case, and then it's hard set, and you try to use Podman, you'll get a deprecation notice, and that's on purpose because we don't want to be using. We're not going to be creating new BoltDB databases for the Podman backend anymore. We kind of want that to deprecate and go away, so we can just eventually deal with the SQLite ones. So that's kind of the story around the database and how that is, and then the one little edge case for it. Back to you guys.
Sounds good. All right, well, let's kind of transition, and we've talked a lot about like where we're at right. Oh, Mark, did you have something?
I don't know, and at the risk of explaining it poorly, but it's just something that I'm super excited about in terms of container hosts in the future. So there's a project called ComposeFS that is being integrated into container storage, as well as in the backend for RPMOS tree. And both of those, both RPMOS tree has always been, and ComposeFS is what's called a content addressable backing store. I could show you on a window, but the point is when you look at the file system, it's actually linked to backing files that are just named after the hash of the file. And so if in container storage, what this is going to mean is that it's deduplication at that file level. So, and regardless of the metadata or the path, if the content of the file is the same inside the container storage, it's only going to be stored once. So you could have 150 pull in 150 different UBI containers. Bin SH is going to be there once. Not only that, when things are instantiated, it shares this backing store with the page cache. So the moment you fired up one container, if you fire up another one with the same base image, most of those base files are already in RAM. Frankly, even if you had content that was the same on different distributions, in different paths with made on different dates, as long as the contents of the file are the same, it would be stored once and loaded into memory once. So bottom line, faster, highly dense container hosts. And so I think it's going to be pretty neat. And to take it a step further, we could unite that. And I believe we're planning to unite that with the file system of the node itself. So just for good measure, if there might only be one copy of bash, even though you have hundreds of containers pulled down, because it's firing up from the base OS. So no demo for that. I'm just
right. Yeah, that's
pretty
really
neat stuff. I mean, it's just going to be like after your first container or two loads up, things are just going to really fly on startup time.
Yeah, that's super exciting. So what else is coming in the future that we want to share here? Any other features you're excited about?
We are gaining support for OCI Artifacts. They're not OCI registries. They're not just for containers anymore. People have any number of use cases. I feel like the use cases are even kind of really being figured out. Like people are just realizing, hey, okay, wait, what if we start using OCI registries as generic blob storage for whatever? And some of them are, and maybe, I don't know if Brent, if you want to give them a couple examples.
Yeah, I'll kind of get started here, and then if we'll jump over to the terminal. Just what Mark was saying, we're realizing that registries can be used to store basically any kind of blob, and there are sensible reasons why you might want to associate a blob or something with a container image. An example might be that you are interested in distributing a data set that goes with your database container image. So rather than jamming the set into the image, you could have it as a separate OCI artifact, and you can have that then pulled and loaded up in it. We actually use this with Podman Machine, and I'll show that example. But to sort of walk through this, we were just sort of thinking, well, maybe it makes sense to show something that everyone will understand. If, let's say, I had a container image and I wanted to be able to publish the container file, instead of sending them over to some other Git repo, I could actually have it as an OCI artifact so that it's part of the manifest and can be pulled by anyone that knows what it is there. The one thing about OCI artifacts is it's not like a FTP server you can go in there and do an LS. You have to kind of know how to creep through manifest, you got to know that something's going to be there and what it is eventually to be able to deal with it. But I think we have even though sort of a simple example, we can make sense. And this will help folks if you've never seen multi-arch builds. You'll get a peek to see some of that. So I'm going to try to touch on a number of topics. But I'll jump over to the terminal here. And I just have a small container file here that's just Alpine, and I add a little, I add bash package to it. And that's the basic approach I'll start with here. So the first thing that we would do in a typical user flow would be that we would build this image. And if you notice, I'm tagging it as an AMD 64 or an x86 64, if you will. I want to tag that so that I know which architecture that one is just for now. And if we go ahead, and typical user flow would be to sort of, this may not totally push, but typical would then you push it out to a registry so that you or someone else can use that. Nothing really new here, but where we start getting into new things is with the Podman manifest command that was put in Podman 5. And the way the syntax works here is you manifest is a subverb. It has verbs underneath it. So Podman manifest create, and then the argument given is, I'll say, the name of the image or the manifest. They're somewhat exchangeable in this particular format. And that's a very quick operation. And then if you're doing multi-arch, the next step you would do is you would associate the AMD 64 image with that manifest. And this is the command to do so. Podman manifest add, we cite the arch as AMD 64. Then we cite the manifest, the fully qualified manifest name, which is their bash Alpine latest. And we cite the image we want added. And that has been added. Now, I did build an ARM version. I'm not going to build it here for you. It's pre-built and been pushed. So I'll go ahead and add that. And then the last bit here is, like we said, let's go ahead and add the container file so that we've got an artifact for that. And that's, again, with a manifest add. Only this time we're going to cite it explicitly as an artifact. We again give the name of the manifest and then the name of the file. And it's all done. Now, if we look in Podman images, you're going to see the AMD 64 tag that we built right here. You see the original one that was pulled to build that. And then you see this is actually a manifest being represented as an image. So you see all that stuff. Now you know what we have. The next logical step for folks is to now push it. So with Podman here, instead of pushing an image, you're actually going to push the manifest. The dash dash all says, hey, push whatever needs to be pushed. And then again, the location. And what it'll do is it'll go through those. A lot of that was already cached, so not really quick. If we go to the Quay website and we look at this particular repository that we're working with, here we can see, I'll refresh just so it shows. We can see that there ends up to be 3 tags. You see the 2 tags for the architectures. And then you see this latest one, which is actually a manifest. You can see that Quay represents that there. And then right here, which hopefully you can see, it's actually kind of difficult because of the color, at least for me, but there are 3 objects letting us know that there are 3 things associated with that. Okay, so let's show the ingestion now. I'm going to show how do you get this? And this is a little bit of a contrived example, but I think gives a lot of insight into folks. When we want to look at a manifest or an image that's remote, we can use a tool that that our team creates called Scopio. And I'm asking for the raw data to come back. The Docker is a transport, Docker : is a transport saying that it's on a registry. And then I'm piping it through the JQ parser. And if we look at what comes back, you get your basic JSON. And here we can see that just like when we looked at it in Quay, we've got an AMD 64 container image. Oh, I pushed it with the same label. This should say ARM. And then we have another one here that's an artifact of type unknown. You can also specify the types. And the way to further down this to get these things is we can still use now that same general approach, and then we're going to add in the hash for that artifact. And we get back another piece of JSON that describes that artifact, which is just a text file. And you can see here the layer it shows that it was initially called container file, and it's a plain text style file. The one thing to sort of look at here is these two hashes here are gonna come back up. So if we look at the original one and get this hash, we can use a Scopio command called copy. Got the raw, and we're going to save it to a directory called pulled. And if we look in pulled, you'll see that down came those hashes that we saw earlier, including some metadata that came down. And if we look at pulled, and we'll see the container file there. Now this could have been anything. It could have been a disk image. It could have been like I said, some sort of binary blob for data. It could have been your AI database. There's lots of various things that could be done here. The way that Podman uses it, not only is Podman there to show you how to put the stuff up there and get it transferred and whatnot, but we actually use this with Podman machine. And this is the command that you can use with Podman in order to initiate and start a machine. And I won't make you sit through this, but the novel part here is that Podman is seeking out where to go get the disk image by looking up this registry reference, and then it's walking through and saying, okay, I'm x86, I need a disk artifact for QEMU, and grab that for me, pull it down, and you can see that pull is going on right there. I'll go ahead and stop it just so it freezes it. But that's how we're implementing OCI Artifacts directly.
Very cool.
Yeah, I'd expect
cool stuff.
More use cases for that. But for example, keeping sig stores, signatures is one area, like where you might want where the sig store community wants it to be attached, right? Why you want it with the signature right with the container that it's been signed. And so that was one of the earliest main usages, but as you can see, like the possibilities are pretty much endless. So we'll see how it goes. Yeah.
Very much kind of Wild West yet. There's not a lot of standards around this, and it may very well end up being that way because that latitude lets people come up with use cases and uses that are really open-ended and purposeful.
Well, do the first people that walk into the space get to define the standards? That'd be great, right?
Something like that.
All right. Well, this has been a great walk through Podman, not just 5.0, but a lot of just Podman in general, right? So, were there any other points you wanted to touch on before we closed up? Because we are just about out of time. In fact, we're just over.
I just say that the Podman, Podman IO has links to mailing lists, chat rooms. Very responsive. There's a community meeting. Everybody's welcome to monthly. And all those links are from podman.io. And for especially, for Mac and Windows users, your first step is really to go to Podman desktop-desktop.io. Oh, and one more thing. If you are just a call for features, if you feel like there are build features that you would like to see in Podman/build that are not there yet, more sophistication, who knows, binary dependencies, directed graphs, talk to us. We're really looking to enhance the build capabilities, so we'd like your input. That's it.
Awesome.
I think I got it.
All right. Well, Mark and Brent, thank you for coming on the show this week, and thank you to everyone who's tuned in live, and thank you for everyone who's watching us after the fact. Remember that if you want to catch this show live, you should like and subscribe. Like to let us know that you like the episode, and of course subscribe so you know when we go live again, or just whenever there's a new video posted. If you want to check out our new Discord community, there's been links in the video, like a QR code at the top and whatnot, and I believe you'll be able to find a link to join in the notes for the episode after we publish. Don't forget about Red Hat Summit. It's coming up in less than a month. I think it's about 3 weeks away. I'm going to be there. I know Eric will be there. Brian, I don't know about you if you'll be there or not, but I know there's going to be a lot of Red Hatters hanging out at Red Hat Summit. Imagine that, in Denver. So if you want to come on out to there and meet some of your favorite Red Hatters, come on out. Let's see. Friday. Don't forget, we've got another Into the Terminal. You'll see me and Scott. I'm dusting off some of my old school systems administration skills once again and walking you through local virtualization on RHEL. So we're going to be covering libvirt, some web console stuff. Yes, Brian, we're going to cover web console, even though it's Into the Terminal. But it's going to be a fun time. So if you're ever curious about how Nate runs his home lab on his RHEL machine in the basement, that's pretty much what we're going to be walking through. And yeah, again, thanks everybody for joining. And I think that's a wrap for today. Any final words, anybody?
Thanks for having us, and thanks for everybody for listening. Appreciate it.
Thanks, Mark and Brent.
Yeah, really appreciate it. Thanks, guys.
Have a great one, everybody.